Hey guys, so I know we posted, or I put on the board that the video notes for tonight are 5.5. I am going to briefly go over 5.4, the questions that we did not do together. I am going to review them so that you can check your work and make sure that it is correct. So 5.4 is the applying properties of special parallelograms. We looked at that last week. But it was up to you to fill out this graphic organizer on your own. So please do that. I will be checking it tomorrow. Make sure that it is filled out and that it is correct. You were also responsible, this was for work in class, for doing the guided practice numbers 1 and 2. That was in class work. Make sure that's done tomorrow. I'm checking 5.4 as well as 5.5. And then let's try it out, okay? So let's talk about this try it out that went with 5.4, the notes for 5.4, okay? It says here rectangle JKLM was plotted in the coordinate plane, and that segment JK has a slope of 3/5. All right, so we know that we're dealing with a rectangle, all right? And so a rectangle, I'm just gonna sketch that looks like a square, but a rectangle. You know, a square is a type of rectangle, but we're going to call this a rectangle, okay? And we know that it has 4 90-degree angles, okay? And we're going to name this J, K, L, M. And it says JK has a slope of 3/5. All right, so these two, JK and ML, are parallel, but JM and JK are perpendicular because when they intersect, they form this 90-degree angle. They intersect right here, and as you can see, a 90-degree angle is formed. So that means they're perpendicular. So that means the slope of MJ is the inverse reciprocal, or -5/3, which is answer choice C. Next question. In rhombus ABCD, where measure of angle EDA is equal to 20, EDA is equal to 20 degrees, and it is a rhombus. What type of triangle is triangle ADC? So ADC, they're talking about this triangle right here. Let's outline it. ADC. Well, this is a rhombus, so all 4 sides are congruent. And all 4 sides are congruent, and the diagonals are perpendicular. So, all right. So that means that, well, because this, right, none of the vertices are 90-degree angles, it's not going to be a right triangle, okay? And that's because neither angle A, C, or D are right, okay? But we know that the diagonals are angle bisectors, so that means these 2 angles are congruent. So these 2 are congruent. Does that really mean anything? Well, what it does mean is that if you look at these 2 sides, they are congruent. Therefore, this is an isosceles triangle. So if that's the case, then these 2 angles are congruent. This is an isosceles, just by the sheer fact that these 2 are congruent to each other. Okay, these 2 sides. So triangle ADC is an isosceles triangle because segment AD is congruent to segment DC. Okay? And everybody knows or should know what an isosceles triangle is and the properties of the isosceles triangle. Okay, so the next thing we have here is number 3, and it says quadrilateral WXYZ has coordinates W, -1, 2, X, 3, 0, Y, 4, -3, and z, -4, 1. Hopefully I plotted those properly. And then I'm just going to connect them. And it says that we need to show the diagonals of wxyz, show that they are congruent. So we are going to just start by just kind of looking at the type of figure that is graphed here. And I'm feeling like it looks like a trapezoid. And it does kind of look like it is a trapezoid. But we would have to prove that. We can't assume, but it really does look like one. It looks like an isosceles trapezoid, as a matter of fact. And so let's draw in, or maybe not. And so let's draw in the diagonals. Let me make sure I have this correct. 1, 2, 3, 4. 1, 4, 1, 2, 3, 4, -3, and 3, 0, and -1, 1, 2. Okay, so let's draw in our diagonals. And so we're being asked to prove that the diagonals are congruent. Well, what can help me prove congruence? Congruent means same length. Length and distance are the same thing, so I'm going to use the distance formula to find the length of wy and of zx. Okay, so I am going to, well, the coordinates are -1, 2, and for y are 4, -3, and I'm just going to plug those in and see what I get. All right, so -3 minus 2, 4 minus -1, and that's going to give me -5 squared plus 5 squared, which is going to be, this is 25 plus 25, so the length of wy is radical 50. I'm not even going to simplify that. All right, for z, my coordinates are -4, 1, and x, 3, 0. Oh, sorry, you can't see. Sorry about that. 3, 0. Okay, and then again, I'm going to use the distance formula. The distance formula tells me that whether or not segments are the same length. They tell me what the lengths of segments are. So 0 minus 1 and 3 minus -4. Alrighty. So it says that I'm showing the diagonals are congruent. So it means that they are. It's not that I'm trying to say whether they are or not. I'm proving that they in fact are. So I have 0, -1, which gives me -1 squared, plus 3 minus -4, which is going to give me 7 squared, and that's 1 plus 49, which does give me 50. So they are congruent. Okay, I'm just going to put a box around their lengths. And then I can make the final statement that segment wy is congruent to segment zx, because 50 and 50 are the same numbers. All right, that's how you would prove that. All right, so it says here, lastly, Lewis concludes wxyz is a rectangle because the diagonals are congruent. Explain his misconception and classify the quadrilateral correctly. So he says that it's a rectangle because the diagonals are congruent. But that is a property of a rectangle, but in this case, there are no 90-degree angles in the quadrilateral shown, and we can prove that. And if you are going to make that type of statement, yeah, you would need to prove it. So that would mean that WZ would have to have the inverse reciprocal of WX. So the slope of WZ is up 1 over 1, 2, 3. 1 over 3. And the slope of WX, if they were perpendicular, it should be -3. That's what the slope would be if they were inverse reciprocals or if they were perpendicular to each other. So let's see if that's the case. So WX, let's see, if I'm going to go from here to here, I need to go up 1, 2, and over and to the left. So up 2, to the left, 1, 2, 1, 2, 3, 4, 2, -4, which is -1/2. Okay, so segments are not perpendicular to each other. But if we checked the slope of ZY, we could perhaps confirm, so segments are not perpendicular, therefore this is not a triangle. This isn't a triangle, but what type of figure is it? Well, I'm thinking that it is a trapezoid, so all I have to prove is that one set of sides is parallel to each other. And to do that, I'm just going to, I already have the slope of WX, which is -1/2. Now I just need the slope of ZY, so I'm going to go from this point, or rather from this point down here. I go down 1, 2, 3, 4. So ZY. So I went down, so that's, negative 1, 2, 3, 4. And to the right, 1, 2, 3, 4, 5, 6, 7, 8. And when that simplifies, it simplifies to -1/2. So they have the same slope. So these are parallel. This is a trapezoid. This is a trapezoid. So notice I didn't just write, it looks like a trapezoid, therefore it is. I actually proved it using slope, okay? And that's something that you really have to get into the habit of doing. Stay tuned for 5.5.